Okay. In this question, you have to illustrate the locus of set that's complex number, right? In an Argand plane, if the amplitude, okay, of you have z minus 1, z plus 1 is equal to pi over 4. Since we know that z is a representation of a complex number, which is like x, a real number, and an imaginary number, right? So you, instead of z, you can replace by x plus yi minus 1. You have x plus yi plus 1 equals to pi over 4. Then what you can do is bring the real number together. So rearrangement, right? Y, so x plus 1 plus yi, and this is equal to pi over 4. Now what you can do is, since we are now trying to find, they are saying the amplitude. So amplitude here means angle, right? So in short, you can write amp. So meaning whatever you are representing here is also an angle. Makes sense, right? Okay, so now what you can do is, this here you can do some rationalization. So keeping this as a and this as b, you know that a plus b multiplied with a minus b will give you a square minus b square, right? Hence okay, what you have is, okay, x minus 1 real number, yi over, so x plus 1, if this is a plus b, you need to introduce a minus b. So just trying to simplify here, okay? This is pi over 4. So if you multiply this to numerator and numerator, what you get is, okay, x, so I'm multiplying the first term and first term, that is x squared minus 1, then this multiplied to this, so we have negative xyi plus yi, then multiply this, you will get positive xyi positive yi, then you multiply this, you have negative y square I square. So I square, since you know that imaginary number is negative square root of negative 1, so I square will be negative 1, right? Divided by, so this is a plus b, a minus b, so which will be a square minus b square, so equals to pi over 4. Okay, so this is still amplitude. Then you have amplitude of, so further simplification, so x squared minus 1 minus plus, same value gets cancelled, so you have plus 2yi minus y squared times 1 negative 1, then divided by x plus 1 whole square minus y square negative 1 equals to pi over 4. This implies that a amplitude of x square minus 1, so you have positive y square, so then plus 2yi over x plus 1 whole square, so minus minus plus y square equals to pi over 4. Now you can use this tan inverse the angle, right, which is modulus of b over a, modulus of b over a. So b here represents your imaginary coefficient of imaginary number, so and so b and a comes from, since we already know that we are representing a plus bi, so b is the coefficient of imaginary number, right? So this implies that tan inverse, so modulus of So your imaginary number right now, okay, is 2 and the denominator, sorry, not 2, 2y and the denominator, right? So you have 2y over x plus 1 whole square plus y square divided by a. Your a here is the real numbers here divided by this, right? So you have x square minus 1 plus y square over x plus 1 square plus y square. You can expand, okay, like this. If you want to clearly see, what you can do is x square minus 1 plus y square divided by x plus 1 whole square plus y square, plus you can write 2yi over x plus 1 whole square plus y square, just to make sure that you see this as a plus bi imaginary number. Okay, so now what we have here is 10 inverse, so 2y over x plus 1 whole square plus y square times x plus 1 whole square plus y square over x square minus 1 plus y square. So this can be cancelled, and what is left is 10 inverse 2y over x square minus 1 plus y square is equal to pi over 4. So if you take 10 inverse to other side, what you have is 2y over x square plus y square minus 1, which is equal to 10 pi over 4. So 10 pi over 4 is 1, right? Since we know that tan 45 degrees is equal to 1. So 2y over x square plus y square minus 1 is equal to 1. So cross multiply, you will get 2y equals to x square plus y square minus 1. So bring all the terms together, so you have this. So now actually this gives you the picture of your circle, right? So it represents a circle, represents the general form of the circle, right? The circle, and here your center and your radius would be different because it is the center is not at 0, 0, right? So the general form is x squared plus y squared plus 2gx plus 2fy plus c equals to 0. For this, the center is negative g comma negative f, and your radius would be g squared plus f squared minus c. So hence, if you compare the general form and the form that you have got, you will be able to extract what is g. So since you do not have x value here, so probably g is 0, and your f is the coefficient of y, right? So f will be negative 1. Since negative 2y is equal to 2fy, so y cancel, 2 cancel, what is left is 1, negative 1. Okay, so and you have value of c equals to negative 1 constant, right? So now your radius is g square plus f square minus c. So your r is equal to square root of 1 plus 1, which is equal to square root of 2, which will be probably 1.4, right? Around 1.4. And your center is also important. Center is negative g, so g value isn't there, so it's 0, and negative f, so which is 0, 1. So now you can actually draw. So sorry, not the circle, but in your graph paper here. So if this 1, 2, 3, so your 0, 1, 2, so 0.1 will probably here, and the radius is 1.4, so 1.4 would be here, 1.4 would be, so if this is 1, probably here, so 1.4 would be, okay, if this is 1 and this is 2, 1.4 would probably here, negative 1, okay, 1.4, let's say it's here, yeah, so that would be your circle, and you are using the straight, not dash line, but straight, okay, continuous line.